All right, hello, my wonderful peeps. Today we're going to be working on writing to graph an inequality, rewriting to graph an inequality. So we have a word problem, and the word problem states, for a party, you can spend no more than $16 on candy. Hard candy costs $2 a pound. Soft candy costs $4 a pound. What are three possible combinations of hard and soft candy that you can buy? So first things first, we have to set up an equation. The three things that we have are that hard candy cost, it's right over here, hard candy cost, I forgot how much it was, hard candy cost $2 a pound, and per LB, and that soft candy cost $4 a pound. And we know that we cannot spend more than $16. So $16 is our cap. And if we can't spend more, that means what we're actually going to spend, so we'll just put a dollar sign, is going to be less than or equal to 16. Because we have $16 to spend, so we can spend 16, but we can't actually spend more than that. So we got to give ourselves for y, and we got to give ourselves x. It doesn't really matter which one you use for which. For this case, I'm going to add that my hard candy is my y, and my soft candy is my x. So I'm going to go ahead and write that in now down here. Oops. So this is going to be my I choose soft candy. So this is going to be my soft candy. And this is going to be my hard candy. All right, and we're just going to go by ones. If we see here, we're just going to go by ones. So it'd be 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8, to just keep things even. Well, I know I need to write an equation based off my x and my y. So in order to do that, I have to figure out, well, it has to equal, the amount has to be less than or equal to 16. So I know I can put my x plus y has to be less than 16, or equal to, and then I know my x, each soft candy costs $4, and each hard candy costs $2. So this is the equation we have to solve. There's a couple ways to do it. The easiest ways to do it would to plug in if our soft candy ended up equaling 0. So if y was 0, how many hard candy could we buy? And we can do that here by plugging in 0 here. And we get 4x is less than or equal to 16. So we divide by 4, and x is equal to 4 pounds. So we can get 4 pounds of soft candy, which would be here. And vice versa, if we do the same thing again, running out of space, I might actually do it up here. We have 4x plus 2y, which is less than 16. If we were to make our x equal 0, that means this would be 0 here, and we're left with just 2y less than or equal to 16, which would, if we divide by 2, would give us y is less than or equal to 8. So you can buy up to 8 candies. It doesn't mean we have to buy 8 candies, but we do have to, we only have 8 candies to spend. So if we draw our line here, it's actually going to look like this. You can also, if you want to do it the normal way, or I wouldn't say the normal way, but put it in slope intercept form so it looks like this. Y equals mx plus b. All you have to do from this equation here is solve for y, and you can graph this way. But I found that this way, plugging in 0 for y, solving for x, and then plugging in x or 0 for x, and then solving for y is the easiest way to do equations like this. So basically, everything inside here, let me get the shading. This one here. Okay. Everything inside here would be our answer. And it says it wants us to choose three possible combinations. Well, we just choose any 3 points inside. We can actually choose these points here, this one and this one, because they still fall inside. So if we did that, let's just choose those 2 points, and then we'll choose this random point here. Let's do this one right here. So the top point here would actually be x is 0, because that's how we found it. So x is 0, and then our y is 8. On the same note down here, our x would actually be 4, and our y would be 0, because we didn't go up anything. And the point here, which is another possible combination, would be our 2. So 1, 2, and then 1, 2, 3. So our x would be 2, and our y would be 3. I mean, there's other possible combinations. There's a ton in here, actually. So you can do that one, which is 1, 1, 3, 1, 1, 4, 1, 5. Even this one here, which is 1, 6, fits. But it only asks for 3. These are the 3 that I'm going to go for here.